What we're going to do on this video is to take a look at your first 12 questions on this practice test for test number 2. I'm going to do this a little bit differently than on the other practice test. I am going to mark up each problem to define what type of problem it is. Then I'm going to mark up each number in the problem, and then I'm going to pick a formula to use. There's this whole process that's involved with this test that's not even really has anything to do with math. It's just sort of how to get the problem set up and solve it. Let me show you what I mean with question number 1. We have all this information about George and what he wants to do with his money. Before I start on anything, I want to recognize that this is a simple interest problem. And in the problem, it will tell you what type of situation we have. I'm also going to mark how much interest did he earn as what we're trying to solve for. Now, the reason I do this is because I see simple interest. I see we're looking to see how much interest he's going to earn. I am going to choose this formula. Interest calculations for a simple interest problem is that formula. And a lot of students have a hard time working through that and figuring which formula to use to solve which problem. So I think that's worth some time to mark up the problem and get yourself going in the right direction. From here, I am going to mark up all of my numbers that I have for this problem. George is investing $7,500. He's going to leave it sit in the bank for 3 years at 8% interest. Don't forget to flip that percentage into a decimal, and he's going to let it, like I said, sit in the bank for 3 years. All we have to do is multiply those numbers together, and I would come up with $1,800. So there's how you would do one like that from start to finish. And I'm going to go over all of this process with all of these problems to show you what I mean. So let's take a look at number 2. Jane has a lot of information here. I see the word simple interest. That's where I'm going to start. What is the total amount? That's where I'm headed. So I'm going to choose this formula, the total amount formula for a simple interest account. So let me mark up my numbers. $2,500, 2 years at 12%. Now, it's a matter of plugging these values in. So I have 2,500. My interest rate is 12%. Don't forget to flip that to a decimal. Move the decimal over 2 places, 1, 2. So what I have now is 2,500 times 1.12 times 2 is 24, and when I multiply those two numbers together, I get $3,100. So my answer for number 2 is C. Okay, so there's how you do one like that from start to finish. Same thing for number 3. What is the amount? Okay, that's what I'm looking for. That has to be repaid, yada, yada, yada. Simple interest, that defines the problem. Also, how much interest will be paid. So this is a simple interest problem, and I'm looking for 2 different things here. So I'm going to use both formulas. Interest is equal to principal times rate times time. That takes care of how much interest. And then how much, what will be the amount, will be this formula. Okay, so I'm using both for this problem. The numbers that I'm going to plug into this equation are 7,200, 5 years at 12%. So let me just plug those in. 7,200. My interest rate is 0.12, and I'm going to leave it sit in the bank for 5 years. So when I multiply all of these numbers together, I'm going to get 4,320 for my interest. My total amount, I have 7,200, 1 plus the interest rate, 0.12 times 5. So I would have 7,200, 1.12 times 5 is 60, and that's going to give me 11,520. So my answer would be choice B, has to repay this total amount with that much extra in interest. So there's how you do number 3. Let's take a look at number 4. Mark up the problem. How many years? Simple interest rate. That tells me what I'm looking for and what type of problem this is. Now, I could use either equation for the simple interest. I'm solving for t, how many years? Let me choose this one because this one's a little bit easier to deal with the algebra. This time I'm solving for how many years t, so I'm going to highlight that. That's my unknown. I have $5,000. It grows to $6,500 at an interest rate of 3.2%. Notice it didn't tell me how many years it takes for this to happen. That's what I'm solving for. So I'm starting out with $5,000. My interest rate is 0.032, and my t time is what I'm solving for. Now here's where everybody has a hard time with this problem. The amount of interest that I earn is not 6,500. That's the total amount. The amount of interest that I earn is I would have to subtract those two values, and I would earn 6,500 minus $5,000, $1,500 of free money. So this is an Algebra 1 problem. I have 1,500. 5,000 times 0.032, that's going to give me 160. There is my t. I divide both sides by 160, and when I do this, I get a t of 9.4 years for this to happen under these conditions. My answer is A, about 9 years. So there's how you do one like that. You're solving for a different unknown. Let's take a look at number 5. I have a lot of things. Find the future amount. A lot of numbers. I see the word compounded, and the game just changed. We're not dealing with a simple interest problem anymore. I am looking for the total amount in a compound interest problem. So here is the formula I'm going to use for that. This A is equal to the principal plus the rate over the number of compounds n per year times t. So I'm going to start with $4,400. I'm going to leave it sit in the bank for 10 years at a 6% interest rate, and I'm going to highlight that word semi-annually, and you'll see why I did that in just a second. So I'm going to start off with $4,400. That's my P. There's my 1. My interest rate is 0.06. Nothing's changed there. Move the decimal over 2 places. N is the number of times this money is compounded per year. Semi-annually is 2 times a year. So that's why I highlighted that semi-annual, and I'm going to leave it sit in the bank for 10 years. So we have the right formula, we plugged in the right numbers, we're all set to go. It becomes a calculator problem at this point. So 4,400, just copy that. 1.06 divided by 2 is 0.3, and I'm going to raise that to the 20th power. Exponent key on your calculator. When I do that, my future amount would be 4,400, 1.03 raised to the 20th power is 1.8061. When I multiply those two values together, I'm going to get 79,46,84. My answer is D. Now, here's where people sometimes get shaky on this. You did not get the exact amount. You were off 5 cents. That's because of the rounding. On your test, always pick your closest answer. All of the answers will be separated far enough, just like these, where this is your only choice. You always go for that closest answer. And if your rounding's off a little bit, that's okay. Number 6, let's take a look at that. Find the total amount. That's what I'm looking for. I see the word compounded. This is the exact same question with different numbers. I'm going to run right to that formula, and that's where this whole thing's going to get started. So I have the right formula. I know what I'm solving for. Starting with $9,000, 16 years, 10%, and I'm going to highlight that annually. So those are all the numbers that go in to the formula. So here I go, 9,000 bucks that I'm starting with. My interest rate is 10%, 0.10. Annual, just like a flower that blooms once a year, they're called annuals. My N is 1, and I'm going to let that sit in the bank for 16 years. Again, pick the right formula, plug in the right numbers, and now it's a calculator problem. So I have 9,000, 1.10 raised to the 16th power. So my future amount is 9,000, and then 1.10 raised to the 16th power is 4.595. My future amount is $41,355. My answer is choice D. So there's how you would do one like that, again, starting from start to finish. Let's take a look at number 7. Find the total amount. All of these numbers, I see the word compounded. This is the exact same problem with different numbers. Future amount. Here is my equation. Wrote that out. Let me highlight the values that are going in. 2,500, 6 years, 16% quarterly. Let's plug these numbers in. 2,500, 1 plus 0.10, quarterly means 4, like 4 quarters in a dollar. And I'm going to leave that money sit in the bank for 6 years. So again, quarterly means your end value is 4. So what I have, my future amount is 25, 1.04 raised to the 24th power. My future amount is 2,500 times 2.5633. That comes from this 1.04 raised to the 24th power. And then to finish this off, when I multiply these two guys together, I'm going to get $6,408.25. I was off a penny with my rounding. I would choose choice B. None of the other values are even close. Let's take a look at number 8. A rich uncle wants to give his niece $9,000 on her 18th birthday. Let's see what we're looking for. How much would the uncle have to invest? That's what I'm looking for today if the money is compounded. So this one's a little bit different. I see the word compounded. That's going to put me with this equation. Now, here's where this one gets a little bit different. $9,000 is the goal. So I'm looking for a future amount of $9,000. It's compounded, invested at 10% compounded semi-annually. And his oldest niece is having her 10th birthday today. And this niece is going to get her hands on the money on her 18th birthday. So this one's a little bit trickier. The future amount that the uncle wants to give to his niece is $9,000. What this problem is all about is calculating how much this uncle needs to put in the bank today to make that happen. So I'm going to solve this for a present value. The interest rate, again, is 10%. The N is 2 for semi-annual. Now the T, the uncle goes to the bank today when the niece is 10 years old. He's going to have a goal of $9,000 when she turns 18. The time he's going to let that money sit in the bank is 8 years, from her 10th birthday to her 18th birthday. So we have 9,000 is equal to P times 1.05 raised to the 16th power. So coming up here, I have 9,000 is equal to P, and then 1.05 raised to the 16th power is 2.183. Now, solving this algebraically, I divide both sides by 2.183, and that's going to cancel these two out and leave me with a value today the uncle has to go to the bank with is $4,122.77. My answer is choice B. So there's the present amount. The goal is $9,000 under these conditions for the niece's 18th birthday. Let's take a look at number 9. We're going out to problem 12 here. This one, what is the effective rate? That tells us right off the bat what type of problem we're dealing with. Now, your effective rate conversion formula is 1 plus R over N to the NT minus 1, where T is always equal to 1. So that formula is a little bit different. What this problem is all about is we have an interest rate, a named rate of 12%. It's compounded monthly, so an effective interest rate takes into account the number of compounds per year. It's what's really going on with your money. So we have 0.12, the 12% interest rate. There's my R. Compounded monthly, my N is 12. My T is always 1, and I'm going to subtract 1 right here at the end. So what I have for this one is I have 1 plus 0.01 raised to the 12th power minus 1. So that's 1.01 raised to the 12th minus 1. This value in my calculator, the 1.01, is 1.1268, and I'm going to subtract 1 and come up with 0.1268. So there's the process involved with that. And since this is a percent, I have to move that decimal over 2 places and come up with 12.68% or 12.7% as my effective rate. Your effective rate is going to be a little bit higher because it takes into the account the number of compounds per year. So there's how you would do that one. Take a look at number 10. With everything being equal, the most important thing you need to pay attention to when you put some money in a bank or borrow some money is look at that interest rate. Interest rate drives the bus with all of these problems. If you have a savings account, you're looking for a high interest rate. If you're borrowing money, you're looking for a low interest rate. Always take a look at that. That's really important in determining which way to go with an account. Let's say you have some options to go with for a loan, and you're looking for a lower monthly payment. So you want a low monthly payment. You want to go with a 30-year loan. A 30-year loan will provide you a lower monthly payment because your payments are spread out over a longer period of time. So that gives you a nice low monthly payment. There are disadvantages to a 30-year loan, but a low monthly payment would be an advantage. Let's take a look at this one. Produces a higher amount of interest and total amount paid, a 10-year loan or a 20-year loan. So the higher that you have to pay back on the loan, including the interest, that's the longer loan. You're borrowing the money for a longer period of time. You're renting the money for a longer period of time. A 20-year loan, you're going to have to pay a higher amount of interest back and a higher total amount. So that takes care of our review for the first part. The second part will cover questions 13 through 25.